Now we shall be using this model for forecasting, because we assume that this model is free from serial correlations, heteroscedasticity, and so on. So this model we can use for forecasting. So what happened last time? So now actually here we shall be forecasting beyond our regression model data, right? We shall be forecasting beyond our regression model data, meaning that from 1991 to 1994, right? So we shall be forecasting beyond our regression model data, meaning that from 1991 until 1994. Okay, actually what we did last time, we estimated the model using data from 1980 until 1999. Sorry, 1980 until 1990, and we shall be using the data from 1991 to 1994 for forecasting. Okay, so this is our model, right? So I go to I go to proc procedure, right? Proc forecast, you can see from here, and here, so here you can see from here, forecast is from 1991 until 1994, and the forecast name is YF, right? What is called YF? That means forecasted Y, beyond our regression model, that is YF, right? And here, and the method would be static forecast, because our model was not a dynamic model. Our model was not a dynamic or autoregressive model, right? The model we have estimated was not a dynamic model. So we shall be doing here static forecast, right? And here here will be forecast graph and forecast evaluation, all will be here. And insert actual for out of sample observation. What does mean by out of sample? Meaning that beyond our regression model. That means the forecasting will be beyond our regression model, meaning that out of sample, right? Okay, so here I take it not, right? I deselect it. That means so that I do, deselect it. So this one is our model. Forecasting model setting is here. Now we can get the result of this forecasted variable, right? So I press OK here. So this one is the outcome of our forecasting model. And you can see from here, forecast sample from 1991 and 1994, and Y is the actual, and YF is the Y is the actual, and YF is here. What is YF? YF means forecasted value of Y. What does mean by Y? Y means dependent variable. Here the Y is the dependent variable. Okay. So, and here what is happening? So, there are many methods are here. You can see from here. There are many methods to evaluate. There are many methods to evaluate our forecasting model, such as root mean square error, mean absolute error, mean absolute percentage error, Thal inequality coefficient, and so all these things are to evaluate the forecasting model. Okay, out of all this model, actually we shall be using this method, root mean square error, right? So that we shall be using as a benchmark, right, to evaluate this forecasting model, whether the forecasting model is good or bad. So root mean square error we shall be using, and you can see, and this one, that means the dependent variable Y has been forecasted. The dependent variable Y has been forecasted, and it is this one, right, this blue line. And actually the whole thing actually is 95% confidence interval. You can see the gap, right, between two standard deviation, right? So this one actually called 95% confidence interval, right? And since this line is passing through these two line, right, I'm telling again, as this line is passing through these two line, so meaning that our forecasting model is satisfactory, meaning that our forecasting model is satisfactory. So we are happy about it, because this line, yellow line, is passing within two standard deviation or 95% confidence interval. Okay, and also our root mean square error, the value is quite small. You can see the value is quite small, meaning that the error is very small, meaning that actual y and the I'm just writing here, this error is very small, only 0.06, meaning that actual y and for, forecasted y is very close, like this. I'm writing here, I'm showing here, what I'm to say here, root mean square error is small, meaning that actual y and forecasted y, they are moving closely, right? Actual y and forecasted y, they are moving very closely, meaning that the predictive power of our regression model is good, right, or satisfactory. Why? Because the root mean square error is small.